Alright, more nonlinear functions. What's the one starting with H? Do you remember? Sounds really fancy. Hyperbola. 1 over x is a classic example. Actually, I really want to explain this a bit. This is to do with, remember there's proportion. You can have direct proportion. I'll just draw it here. Y equals x is a good example. As x gets bigger, y gets bigger. So see, it's just a steady line. Doesn't really matter if you have a 2 there. Just means the y gets bigger faster, or 5, or even a 0.5. That doesn't really change the fact that it's as x gets bigger, y gets bigger. That's direct proportion. But if we look at 1 over x, it means as x gets bigger, the value of y is getting smaller and smaller and smaller. And as x gets small, when x gets near 0, the value of y is actually very big. And in fact, this graph, technically, it's called an asymptote. It goes to infinity. It's like a limit. It never quite gets there. And you'll notice this line gets extremely close. But if I zoom in enough, there's always going to be some tiny gap. Okay? The same same down here. Okay? If you zoom in enough, there is a gap. In fact, look how big that gap is. It's not even close. Yeah, I'm just making it take longer when I zoom out. Right? Now it gets closer and closer and closer. This is applies to quite a lot of things actually. So for example, distance, speed, and time is a good example. Like for example, I'll put a number in here. I'm trying to think. If you want to travel 5 kilometers and you're traveling at this speed, if you travel at 5 kilometers per hour, it'll take you 1 hour. Okay, but if you travel at 10 kilometers per hour, it'll only take you, that's half an hour. The value there is a half. Okay, half an hour. Do you get what I'm saying? If you travel, so we're saying how long to travel 5 kilometers. If you travel at 15 kilometers per hour, it'll only take you about, that'll be 0.33 hours or whatever. Okay, it just happens, pretty much anything where as this thing increases, the other one decreases. So probably the amount of, you could think of it, I'll draw another one. 2/3 of x. Oops, not s, x. This could be like, the more you study, the more your marks go up. Okay, direct proportion. See, this is where you want to be. All you have to do is study, guys. That's it. The number of, here's another one. Why are they capitals? I didn't type capital. Oh, I had caps lock. Alright, here's a good one. Alright, this one shows the number of videos you watch of Mr. Reed explaining things. This is where your marks go. That's what happens to your marks. So you want good marks, just watch a few videos, boom! Alright, that's just a made up example though. For this one, I'll just change it to a 1 again. The shape stays about the same. This might be the amount of time you spend on Facebook, and this is what happens to your marks. Maybe let's make it 100. Okay, so this is your marks in a test. Okay, so if you spend 2 hours a week on Facebook, then your mark will be 50. Okay, if you spend 5 hours a day on a week on Facebook, your mark's gonna be about 20 is what we're looking at. Wait, 20, yeah. If you're spending 10 hours a week, you're looking at 10 or whatever. So that's the type of relationship. You'll also notice it's negative here, because a negative, if you divide by a negative, you still get a negative. Alright, that's hyperbolic. Let's do exponential. See if you remember what it looks like, and what it is. So just giving you a chance to think. For example, 2 to the power of x. Okay, this is very different from x to the power of 2. x to the power of 2 just means x times itself, x squared. So, 20 times 20 is just 400. It's pretty big. 10 times 10 is 100. No big deal. But 2 to the power of 20 means 2 times 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 2, 20 times, which is actually a million. So no matter how much I zoom out, until these numbers get up to a million, it's not even going to get, up to where 20 was. So see how that, well, they're actually both pretty vertical, but that red one especially is almost vertical. Let's get rid of that one. See how it just looks silly. It goes across and then straight up. But we're not interested in that aspect. We're interested in focusing on this. This is how you'll normally draw it. And to be honest, I don't think you have to do many. But that's just called something exponential. Okay, let's do a more, if I make it a number a little bit more than 1, then you get more of a slightly more steady growth. But still, it still turns and pretty much becomes vertical. See what I mean? So yeah, that's pretty much it. Again, you can even just add 1. The whole thing shifts up. Let's just do 2 again. Let's zoom in a bit more. So you should see 1 is now the cutoff. It'll never touch 1. Or 5, it'll shift up to 5. Now I know it goes through 6, but that's because it normally goes to 1 anyway. So it's shifted up by 5. You can take away 1. Now minus 1 is the cutoff, and it actually goes to 0. Another thing you can do is, what if it was a fraction, like 0.6? Okay, now it's the opposite way. As you keep timesing by 0.6, you get smaller and smaller. But if you work backwards, dividing by 0.6 is kind of like timesing by a bigger number. So it gets bigger and bigger. Anyway, so it's in reverse. This also works even if you have like a negative power. 2 to the power of minus x. Minus basically means instead of times, divide. So that's why it's the opposite. So if I do, what's 1 divided by 2? Like, that's a half, right? If I do 0.5 to the power of x, you notice those are exactly the same. They're on top of each other. Okay, it's the same thing. Alright, I'll leave it there for now.